Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test. Here we have to find the derivative of this function y equals 2 over 2x plus 1 using first principles. First principles, that is the key set of words right there. And if you remember the derivative using first principles from the lecture videos, it's basically that difference quotient, right? The limit as h approaches 0 of f of x plus h minus f of x all over h, like that. Right, we're going to have to use that fundamental definition. You can't just do this with quotient rule or with chain rule. You got to put it through this if you see them asking by first principles, right? Or by using the definition of the derivative. That's another way this could have been worded. So be careful on a test if you see that wording. Don't just put it through the other rules that we covered later, like quotient rule, chain rule. We could use those to check our answer. So I'll do that at the end, actually. I'll take this. I think on this I could use chain rule. You could use quotient rule as well, but whenever I just have a constant in the numerator, I like to bring up whatever expression I have in the denominator, put it to -1. So anyway, we'll use the chain rule at the end to see if we get the same answer that we do with the definition, but you're going to get all your marks by using the definition in this particular case, or in any question that asks you to derive it using the definition or first principles. So let's get into it. So what would happen, we would have the limit as h approaches 0 here. Now f of x plus h, so we got to plug in x plus h into the x values of the function. So we'd end up with 2 over 2 bracket x plus h plus 1, right? So for this, I just plugged in x plus h for the x value minus f of x. That just stays as it is. So that would be 2x plus 1, and that's going to be all over h, like that. And so from here, we just have to simplify this limit, right? We want to try to get this h out of the denominator. So cancel it out, hopefully, with some other h that's going to be floating around. And then we could plug in that h value of 0 to get our final derivative, right? So we have to try to take this and algebraically manipulate it somehow in order to cancel out that h. So what I'm going to do is I'm actually going to take what's in these brackets here, this expression, to the side, and let's see what it could simplify to. Now this 2, right, in the x plus h, I'm actually going to distribute it. So this would be what, 2x plus 2h plus 1 minus 2 over 2x plus 1. Okay, so what I'm doing again, I'm just taking this expression in the green brackets in the numerator. I'm just going to simplify it on the side, and then we'll bring back whatever it simplifies to into the overall limit, and then we'll work with the overall limit after. Okay, so what's going to happen here, these are subtracting, so we got to get a common denominator, right? Now these two are completely different factors, right? So we have to just basically multiply these both by each other in the denominator, right, to get a common denominator. So basically what happened is this, in order to get this common denominator here, I had to multiply this by 2x plus 1. So I got to multiply this 2 by 2x plus 1. This 2x plus 1 I have to multiply by 2x plus 2h plus 1. Just got to multiply the top here by 2x plus 2h plus 1, like that. And so what we would end up having is 2 times 2x plus 1 from this minus 2x plus 2h plus 1, like that. And then we have to expand all of this here, right? So this would be what, 4x plus 2 minus, distribute that -2, so it would be minus 4x minus 4h minus 2 all over that same denominator. Yeah, so this cancels out, this cancels out, this cancels out, this cancels out. And so we are left with a -4h over that same denominator here, 2x plus 2h plus 1, 2x plus 1 like that. So this entire expression in the numerator simplified to that right there. And so I'm going to take that and plug it into this green bracket. So we'll have the limit as h approaches 0 of this expression. So let's just put that in brackets. So this will be negative 4h all over 2x plus 2h plus 1, 2x plus 1 like that. And then I've done this in the lecture videos that when I'm working with like a rational expression, a rational function like this, and I'm using the first principles, instead of dividing it by h, I like to multiply it by 1 over h, right? Because dividing something, if I'm dividing by h, that's like dividing by h over 1, which is the same as multiplying it by 1 over h, right? So instead of dividing it by h over 1 here, I'm going to write it as multiplying it by 1 over h. Okay, you don't have to do this, but the reason why I like to do it is because then you could clearly see the h's cancel out like that, versus if it's over here, it's not as clear to see because there's like a fraction in the numerator and then this h is just by itself. But over here, it's a little bit more clear to see how the h's cancel out in the numerator here and then in the denominator here, because everything is just multiplying. So dividing by h, same as multiplying it by 1 over h. And now that the h canceled out in that denominator, we could plug in 0 for the remaining h's, and the only remaining h is this one here. So this expression is going to go away. So we'd end up with negative 4 over 2x plus 1 in this bracket times 2x plus 1. And so we'd end up with negative 4 over 2x plus 1 squared, like that. So that right there is going to end up being the final answer, right? That ends up being the derivative of this function. And then, as I stated at the beginning, we can now, since we know all the rules, we can check. If you have time on a test, you might as well check your answer with, in this case, again, you could use the quotient rule. You could also use the chain rule. It's pretty nice that you could check your answer too, right? In chapter 1, we didn't know all these different derivative rules, right? So when we found those general expressions for the slopes of the tangent with the difference quotient, there was no way to check it, but here we can check it. So again, you could do the quotient rule. I'm going to do the chain rule, so I'm going to rewrite this as 2 times 2x plus 1 to the power of negative 1. Okay, and so what's the derivative here going to be? So with the chain rule, we bring down the negative 1. Negative 1 times 2 would give us negative 2. Then we'll have 2x plus 1. We keep the inner function the same. Subtract 1 from the exponent. That's going to be negative 2. And then we have to multiply by the derivative of that inner function, which is 2. And then this 2x plus 1 is to the negative 2, so we could bring that down to the denominator, right? So that would be 2x plus 1 to the power of positive 2, negative 2 times 2. That gives us negative 4, which is the exact same thing that we got using the first principles. Now, might as well, we could also do the quotient rule, so let me quickly show it. If we did the quotient rule, on this, what's the quotient rule? You take the derivative of the top, which is just 0 in this case, times the bottom, minus the top, left as is in the numerator, times the derivative of the bottom. The derivative of 2x plus 1 is 2, all over 2x plus 1 squared. That goes away. Notice we end up with negative 4 over 2x plus 1 squared. Right, so with the quotient rule, with the chain rule, we end up getting the same derivative that we got using the first principle, so we could be pretty confident that that answer is correct. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.